Hello, my product prototype that demonstrates Gemma4 capabilities is called GizmoGuard, a personal low budget safety guard that can watch things. Anyway, that's a fun name, but underneath it's about bringing AI closer to the edge. Today, I would use this bot to spy and guard my sacred mug and detect if anyone is trying to move it or steal it. And I'm Sasi Perry. I'm self employed with my LLC, Fourth Quest. This is a daughter driven idea and design. My daughter seldom gets nightmares that someone casing our house when we were away, and she also is worried if someone sneaks into her room and take away her most favorite fluffy toy. Immediately, she got an idea to make a guarding robot to safeguard her favorite things. That's how we started this whole thing, and then Gemma 4 models came handy. This is what the prototype we came up with on paper, which ended up as real model that we will see shortly. And the goals of this project when we started were that it has to be kid friendly, fun filled bot, but that still works. Zero budget. I have no budget allocated to this. And I wanted this to be running locally, like the AI models, everything, and private, and no data goes out to the internet. And the design has to be as simple as possible and so support multi-modality instead of chaining multiple models, one for chart, one for imaging, one for something else. And it has to be speed and not so memory intensive and as accurate as it could be. And edge device compatibility is a thing that we were looking for. And what I used in this prototype that I will demonstrate is my Pi 0W, the generation 1 oldest Raspberry Pi that I had for maybe a decade or more. So I reused that. And an EduCam that's attached to my Raspberry Pi, and a SD card to go into the Pi, and my laptop, where actually in this case for this demo my models are running, because the Pi 0W probably is not the best one to run my models. So for now I am running on the laptop, but I tested with high end Raspberry Pi 0, and there you could actually happily run these models. That's possible. And on the Pi, I have a Python program running which would take the pictures and compare the scene, and if there are any if there is any scene change, or if any motion detected or people detected or the mug is not there, because it's going to watch my mug, it's going to detect, and only the when such a change is detected, it would send the pictures to the backend, and my models are running in the Docker model runner locally, and the backend REST API is built using Java, Spring Boot, and Spring AI. That's where the Pi program running on my Raspberry Pi is going to send the images to. And the models that were used are Gamma 4 4B and Gamma 3 4B. Just to compare, contrast 4 and 3, 3 appeared much faster. 4 is still acceptable and faster and more accurate and intelligent. At super high level, this is the kind of architecture. So as you can see, the Edu camera is attached to the Pi, and Pi, the Python program running, and that does the job of frequently continuously taking thumbnails, and when some change is detected that's supposed to be notified, a considerable change, only then it takes the full quality image, not a thumbnail, and send that to the backend for further analysis. And using the REST API that's Spring Boot Java based, and which is using Spring AI, and the Spring AI is going to send the relevant data to the backend model running in my Docker model runner, the Gemma 4 models, to analyze the image for the details like the background and the scene. If people are detected, their emotions, gestures, and everything, the complete analysis, and then detect if they have malicious intentions or if they are looking okay. Mm, Accordingly, it will send alerts and the response, and it can also recognize the pre-configured known people, and any people that are not pre-configured and unknown, it will call it as strangers. So it can do that as well, the Gemma4. And the response is sent back, which is going to be used by the pi again, and the overall is going to speak what's seen. And it has a system prompt in general. This is the high level of the system prompt. It can first see if the sacred mug is in safe position. If not, it'll alert a thief alert. If it sees any people, and if they are pre-configured, like there are few people I pre-configured, that's Bob, Ceci Perry, that's myself, Lisa, Alice, everybody else is a stranger. And if it detects a person known, then it will call out. And if the emotions, gestures are analyzed, and if any malicious intention is detected, it would report that as well. If they look nice, then it would be reported. For example, Lisa is a picture of a lady that is told to be a trustworthy and pleasant woman, and that's what it is going to detect. And this is the gist of the system prompt that will be provided in addition to the image to the model. And now let's see the demo. And to demo, I SSH into my Raspberry Pi, that's this. And I'm going to run the program. It's starting, and my Spring Boot application is running. And here, as you can see, there is a Raspberry Pi attached to this bot, and there is an Edge camera, and that's watching my sacred mug. Now, it took a picture, as you can see in the logs, it took a baseline image and captured, and it is taking pictures, but there is no change detected because the bug is not moved, there is no scene change, nothing changed. So it does nothing. But now when it detects a change, let's see what happens. Now I'm going to put an image to replicate the real time. In reality, it is supposed to be real people, but that's not possible to be demoed. So I have some pictures that I made using AI, and I'm going to use those pictures to demonstrate its capabilities. Now, as you can see, change detected, but it takes the thumbnail, but there is no change detected, so it reported nothing to my Spring Boot backend application. Now let's see what happens. And as you can see, there is a change detected, so it is capturing full resolution evidence, and it is sending to the backend. And this is my Samba share with my Raspberry Pi. It shows that it captured the image. And
Gizmo Guard Hero K, analyzing the image. It appears to show a woman in a blue uniform with a badge. She is smiling and looking at the camera. It's Alice, the nice lady who can be trusted with the mug.
That's what the system prompt given as. That's how it is trained. So it recognized Lisa. Now this person is a stranger. He is not configured. Let's see what it's going to say.
Gizmo Guard Hero K, scanning the image. There is a man in a suit. He appears to be looking directly at the camera with a slightly serious expression. It's difficult to determine if he's a known individual, so I'll classify him as a stranger.
That's as expected. And whatever the images it captured, I created a small web application to show what the camera saw.
Gizmo Guard Hero K, analyzing the image. There is a man with glasses and a beard holding a Starbucks mug. He appears to be looking down with a somewhat serious expression. It seems like he's enjoying a pastry alongside his beverage. I see Bob.
It detected Bob. Bob is one of the people that's configured. And this is a trained thing as well. Let's see what it does.
Gizmo Guard Hero K. Analyzing the image. Stranger. I see a woman with short gray hair, wearing a red hoodie. She appears to be smiling and looking directly at the camera. It seems she is a stranger.
And this is a AI generated imagine picture of myself, and let's see if it's going to recognize it as me.
Gizmo Guard Hero K. Analyzing the image. There is a woman with black hair, glasses, and a bindi dot on her forehead. It appears to be Shasi Perry, the owner of the sacred mug. She is smiling and looking directly at the camera.
Now let's see, take the mug away. And it should be alerting because it can't see a
Gizmo
mug.
Guard Hero K. Analyzing the image. There is a rubber ducky on a shelf, and a roll of washing hand soap. I do not see the sacred mug with the engraved text. Stranger.
And towards the end, let's see how it manages the real people.
Gizmo Guard Hero K. Analyzing the image. The wooden sacred mug with the engraved text. Sometimes you forget that you're awesome, so this is your reminder, is clearly visible and in a safe position. It appears to be resting on a shelf, looking quite proud of itself. Mug is in safe position.
Now let's see. I turned the camera towards myself, and then how it detects the real image and if it is able to detect.
Gizmo Guard Hero K. Analyzing the image. I see a woman with black hair, glasses, and a bindi dot on her forehead. She appears to be wearing a green shirt and is smiling slightly. It appears to be Shasi Perry, the owner of the sacred mug.
It did recognize. Um, Let me stop the program so it will not keep speaking if it detects anything. Um, yeah, as expected, it recognized the real
Gizmo
people
Guard
also.
Hero K. Analyzing the image. I observe a wooden coffee mug with engraved text reading, sometimes you forget that you're awesome, so this is your reminder. It appears to be in a safe position. I see Shasi Perry, the owner of the sacred mug, standing in the image. She has black hair, glasses, and a bindi dot on her forehead, looking somewhat surprised.
Yeah, that's because it saw me in over here. There is a picture. Um Anyway, it behaved as expected. Even with the real people, it was able to capture. And actually, here I have the wheels, and the battery is off, but there is a battery driven wheels. So if I turn them on, the switch is hiding here. It can actually keep moving. These wheels can be moved, and then it can keep taking the pictures, and the same thing happens. It's going to analyze stuff. um, Anyway, now let's see what I have here. The technical details, we will probably see some technical details next. So here, let's keep the web application away for a minute. I have my Docker model running, and so I also have MySQL. I did not enable the chart memory or the it's not RAG based yet, but the chart memory can be enabled, which is already configured in my Spring Boot application, in which case this is supported by Spring AI, in which case it would have the context, so it can compare with the previous things and remember the chart, and then it can correlate. However, in this case, I did not enable chart memory, but if I did, it would save the data to this table. And my Docker, let's see, Docker mm, model list to see what models I'm running. So this is small way. I'm not using that because that's not that is very lightweight, and I'm able to run that on my Pi, but it is not accurate. It's not multimodal. Um, so that's not going to work. So I tested many models. They are very accurate, but then they're not as efficient as this one. So then I tested with Gemma 3 and I tested with Gemma 4, and I settled with these two. Based on the situation and who I'm presenting, and based on the time and accuracy, I switch between these two models. But for now, I'm running Gemma 4. And here is my Docker and the logs, as you can see from the demo that I just did. And my Spring Boot application. This is the Spring Boot application running, and as you can see, that got the responses as were spoken out, the voice enabled, and these are the model configured. And my Pi program, let's have a quick look at the Python. So this is my Python. It is doing a whole lot of things to narrow down whether there is a scene change, whether there is any person visible, because otherwise I don't want my Pi to bombard with images every few seconds or every microsecond. So I have a lot of logic to detect the real change, and um, only use thumbnails for that purpose, and take evidence, full resolution only when there is a change, and send to the REST API only when this is the REST API to the analyze endpoint, that Spring Boot, only when there is a there is a change. So I have some logic here to calculate the pixels, and add some threshold to do the difference between these pixels, and uh, finally determine whether or not there is a scene change. And it considers ambience lighting also. So I set it to a default ambience light, and then when the lighting changes, I have some logic to see actually it is just a light change or real change, and all that is happening in my Python program. Now let's see. We saw the technical details, we saw the Python, Docker, backend REST, and Docker model runner. Future possibilities. What I really want to do is, instead of those static wheels that go in whichever direction possible, there is no control. I want to have Pi4j and Spring Boot for Pi4j starter on my Raspberry Pi, and then use GPIO header and use server based wheels, so it can be intelligent and move in a direction I want it to move, probably follow, have some noise sensors, and then follow the sound direction, and then capture images and then send. And now right now video is not enabled, probably also capture some videos and text, mail, MMS, those kind of capabilities, video streaming, and some rack capabilities that are not right now there, but I could do that as well. And anyway, the database capabilities and storing this data is already enabled. However, uh, generating dashboards or reports is not there. All I have is just a small web application that shows the images it captured. And so that's another possibility, future possibility that I'm looking at. And some model improvements, yeah, to add something more intelligence, to dynamically detect the people, and after enabling RAG, instead of just a few static people that it is trained on, like provided in the system prompt, instead I wanted to make it a little more dynamic. And That's all for the demo. And I have this code available on my GitHub, github.com, Sasi Perry, and I'll share the repository name. And that's all. Thank you.